Welcome everyone. Today we are moving into KMO2, KTO2, which focuses on quality standards, quality systems, quality assurance, quality control, inspection, testing, conformance, and continuous improvement. These are the core building blocks that ensure products consistently meet customer, regulatory, and organizational expectations. As production supervisors, quality is not something we check at the end. It is something we build into every step of the process. Our responsibility is to make sure every shift, every operator, every procedure, and every piece of equipment is aligned to quality requirements. During today's session, we will explore 1. National and international quality standards. 2. ISO frameworks and SABS requirements. 3. Quality management systems. 4. Quality assurance versus quality control. 5. Process conformance. 6. Inspection and testing. 7. Variation and measurement. 8. Corrective and preventive action. 9. Lean thinking and continuous improvement. 10. Waste reduction. 11. Root cause analysis. By the end of this session, you will understand not only what quality systems are, but how to apply them, enforce them, and lead your teams in a way that supports quality excellence. This knowledge directly prepares you for EISA because KTO2 forms a major part of assessment scenarios and workplace demonstrations. Let's begin by grounding ourselves in the bigger picture of quality, the standards that guide everything we do. Quality standards are formal, documented expectations that define how products and processes must perform. They guide organizations to operate safely, consistently, and responsibly. Quality standards detail the specific requirements for 1. Product safety. 2. Product performance. 3. Process consistency. 4. Environmental responsibility. 5. Customer satisfaction. 6. Legal compliance. Standards ensure that no matter who performs the task or which department produces the item, the output remains predictable, stable, and fit for purpose. They form the foundation of all quality systems. SABS develops and monitors standards specific to South Africa. Many industries require SABS approval to operate, especially in manufacturing, chemicals, and consumer goods. ISO standards are globally recognized. The most important for production supervisors include 1. ISO 9001, Quality Management Systems. 2. ISO 14001, Environmental Management. 3. ISO 45001, Occupational Health and Safety. ISO ensures that production processes worldwide follow similar expectations of consistency, traceability, and improvement. Organizations use standards to 1. To assure customers of product reliability. 2. To reduce errors, waste, and rework. 3. To meet legal and regulatory requirements. 4. To ensure international competitiveness. 5. To continuously improve performance, standards give a company structure. They prevent guesswork and ensure uniform decisions across shifts and departments. Now that we understand the standards organizations work toward, let's look at the systems used to implement them. A quality management system, QMS, is the framework an organization uses to manage and control quality. It connects policies, procedures, monitoring, training, and continuous improvement into one structured approach. A QMS describes how an organization 1. Plans quality. 2. Controls processes. 3. Records performance. 4. Manages non-conformance. 5. Trains staff. 6. Ensures compliance. 7. Improves continuously. Everything in production links to the QMS, from SOPs to checklists to documentation and audits. 1. Policies and objectives. Statements that describe the company's commitment to quality and how success will be measured. 2. Standard operating procedures, detailed instructions describing how each task must be performed. 3. Forms and records evidence that procedures were followed. Checklists, inspection sheets, test results. 4. Corrective and preventive actions. Structured responses when things go wrong. 5. Internal audits. Regular checks to ensure procedures are being followed. Now let's take a look at the benefits. 1. Reduces process variation. 2. Supports consistent production. 3. Builds customer trust. 4. Improves operational discipline. 5. Ensures traceability. 6. Supports EISA level workplace expectations. Now that we understand the system, we need to differentiate between two critical functions: quality assurance and quality control. Although often confused, these functions serve different but complementary roles. QA is proactive. It focuses on preventing defects before they occur by controlling the process. Examples of QA responsibilities are: A. Approving specifications. B. Approving SOPs. C. Verifying training. D. Reviewing documentation. E. Monitoring the process. QA ensures that everything is set up correctly so that defects are less likely to occur. Now, let's take a look at quality control. QC is reactive. It checks the product after it has been produced. Examples of QC activities are: 1. Inspecting finished goods. 2. Testing samples. 3. Lab analysis. 4. Measuring dimensions. 5. Verifying packaging. Remember, if QA controls the process, QC checks the result. Supervisors interact with both QA and QC daily. You must be able to A. Escalate non-conformances, B. Support investigations, C. Review inspection results, D. Enforce SOP compliance, E. Communicate quality expectations. Now let's move into conformance monitoring, inspection and testing, where supervisors spend much of their time. Conformance means that the product or process meets the required standards and specifications. Supervisors ensure conformance by: 1. Monitoring operators. 2. Verifying correct equipment use. 3. Ensuring correct material selection. 4. Checking machine settings. 5. Reviewing checklists. 6. Spot checking outputs. Now let us move on to types of inspections. Inspection is the visual, physical, or documented evaluation of a product or process. Common types include: A. Incoming inspection. B. In-process inspection. C. Final inspection. Inspections identify problems early, before they progress further down the line. Testing uses measurements, tools, or equipment to verify that a product meets the required specifications. Examples are: 1. Weighing. 2. Measuring dimensions. 3. Pressure testing. 4. Chemical analysis. 5. Electrical testing. Testing provides objective evidence, which is essential for traceability and decision making. All processes experience variation. The key is controlling it. Types of variation are: 1. Common cause variation, natural. Expected variation. 2. Special cause variation, abnormal, resulting from problems. Supervisors must identify abnormal variation early and escalate immediately. To manage variation effectively, we now look at control charts. Control charts visually show when a process is stable and when it is out of control. Now let us take a look at what control charts tell us. 1. Is the process consistent? 2. Are there trends developing? 3. Are there sudden deviations? 4. Is intervention required? Now, the question is, why supervisors use control charts? 1. To prevent defects. 2. To identify patterns. 3. To take corrective action early. 4. To communicate with QA. Understanding data is not optional at supervisor level. It's a requirement for quality leadership. Now let's move into continuous improvement, the mindset that connects everything we've discussed so far. Continuous improvement, 1PEA, is the ongoing effort to make processes, products, and systems better. 1. What CI means for supervisors. A. Looking for small daily improvements. B. Reducing waste and unnecessary steps. C. Working with teams to solve problems. D. Sharing ideas across shifts. CI is not a project, it's a culture. 2. Lean principles. Lean focuses on removing waste called muda and improving flow. The 8 wastes include A. Defects. B. Overproduction. C. Waiting. D. Non-utilized talent. E. Transportation. F. Inventory. G. Motion. H. Extra processing. Supervisors must be able to identify waste immediately. Kaizen small improvements. Kaizen promotes continuous small steps of improvement driven by employees. Kaizen works because it's simple. It empowers operators. It encourages ownership. It improves morale. 4. Root cause analysis, RCA. RCA helps identify the true cause of a problem so it does not happen again. Common tools are 5. WHYS, fishbone diagram, fault tree analysis. The goal is not to blame. The goal is to find the real issue and fix it. And now let us move on to 5. Corrective and preventive action. Corrective action fixes the problem that occurred. Preventive action prevents the problem from occurring again. Kappa connects CI, QA, QC, and supervisor responsibilities into one system. Now, let's wrap everything together for today. Today we explored the full scope of KMO2, KTO2, including 1. National and International Standards 2, ISO Frameworks 3, Quality Management Systems 4, QA versus QC 5, Inspection, Testing, and Conformance 6, Variation and Control Charts 7, Lean and Continuous Improvement 8, Waste Reduction 9, Root Cause Analysis 10, Corrective and Preventive Action. These concepts prepare you not only for your ESA, but also for high-performance supervision. Quality is not an event. It is a way of thinking, working, and leading. As supervisors, your behavior, decisions, communication, and discipline directly influence quality results. When you lead with a quality mindset, your team follows, and the entire production system improves. Thank you everyone for your attention and participation today. See you at the next session.